Welcome to SAT Climb. Look at this polynomial. Nobody is asking you to expand it. Written this way, it has already told you where its graph hits the x-axis. 3 numbers hiding in plain sight. The SAT says the same thing 3 different ways. Zero of the function. Factor of the polynomial, x-intercept of the graph. If x minus is a factor, then f of it is 0, and the graph crosses or touches at a1 fact, 3 names. When a question changes the wording, it has not changed the work. Here is the money move. F of x equals x plus 3 times x minus 1 times x minus 4. To find a 0, you ask, what makes this factor 0? X minus 1 is 0 when x is 1. X minus 4 is 0 when x is 4, and x plus 3 is 0 when x is negative 3. Watch the sign. Plus 3 in the factor means negative 3 on the graph. The zeros are negative 3, 1, and 4, and you never multiplied anything out. Now the tails. End behavior comes from one term, the leading one. Multiply just the first pieces. X times x is x cubed. Degree 3, odd, and the coefficient is positive, so the graph comes up from the bottom left and leaves through the top right. Odd degree, opposite ends. Even degree, same ends. Negative coefficient flips both. That is the entire rule, and expanding never enters it. One more thing the factors tell you. Look at f of x equals x minus 2 squared times x plus 5. The zeros are 2 and negative 5, but they behave differently. The exponent on x minus 2 is even, so the graph touches the axis at 2 and turns around. The exponent on x plus 5 is odd, so it cuts straight through at negative 5. Even exponent touches. Odd exponent crosses. Your turn. F of x equals negative x plus 1 times x minus 3 squared. Name the zeros, say which one the graph crosses, and describe the 2 tails. Pause here. Zeros first. X plus 1 gives negative 1, and x minus 3 gives 3. The exponent on x minus 3 is even, so the graph touches at 3 and crosses at negative 1. The leading term is negative x cubed. Odd degree, negative coefficient, so it starts high on the left and falls to the right. 3 traps. 1. The sign. X plus 3 is a 0 at negative 3, not positive 3. 2. Assuming every 0 is a crossing. An even exponent means the graph only touches. 3. Expanding the whole polynomial to find the tails when the leading term already told you. Read the factors, not the product. Polynomial zeros solved. Every factor hands you an x-intercept, the exponent tells you touch or cross, and the leading term decides both tails. Start free at satclimb.com.